Hello everyone. Today let's solve the problem number Leetcode problem number 338, counting bits. What the question says: given an integer n, return an array answer of length n plus 1 such that for each I 0 less than or equal to I, they have given this one less than or equal to n. So answer of I is the number of ones in the binary representation of I. So example 1, they have given input n equals 2, output has to be 0, 1, 1. Explanation, they have given 0 in the binary representation is 0, 1 in the binary representation is nothing but 1, 2 in the binary representation is nothing but 1, 0, right? So that's what they have given. So the total this thing is nothing but 0, 1, 1 output. So same thing goes with the example 2 as well. So let's try to write the code and understand with the example 1. Understand the code with the example 1. You can check for the example 2, right? So initially what I'll do, let's consider the, let's initialize an empty array to store the results. Let me take results or result. I'll take, give this empty array. So next we will loop through all the numbers from 0 to n. For this, we'll just make use of for loop 0. This is n plus 1. So why we are making use of n plus 1? Here they have clearly mentioned, given an integer n, return an array answer of length n plus 1. So we are considering n plus 1 over here, right? So then what we'll do, we'll convert the current number to the binary string. First what we will do, we'll have the particular number. They have given n equals 2. First we will convert the number to binary number. Here you can clearly see. We are converting the number to binary string first, and we will remove all the zeros in the binary string. So if we remove this 0 from here, right, remove zeros and count the remaining ones. So here 0 doesn't have zeros at all. First initially we'll give 0. Next for 1 we have got 1. For 2 we have got zeros and 1 is present, and we are eliminating the 0. So we are getting 0, 1, 1, right? So we can convert the current number to the binary string, remove all the zeros and count the remaining ones. How can we write that in the code? So I'll just give let count ones equals convert. To convert to string, I'll just make use of toString 2, and let's make use of split 0, and finally let's join, right, length. So this is fine. Next what we will do, we'll push the count of ones in the result array. So here we'll, in this example, in this case we will be removing this one. We'll just count the ones and we'll push that one to the array, right? So the output that we have got here is 0, 1, 1. So let's see here. Let me come here. It will be the result dot push of count ones, right? So this is fine. Next what we will do, we will return the array containing the number of ones for each number from 0 to n. Nothing but we will return a result, right, in simple terms. So let me format the code and let me hit the submit. So this works absolutely correct. So let's consider example 1 and try to implement the same accordingly with the code, right? So I'll just come here. So let's consider this example. N equals 2, output is 0, 1, 1. So what, let's come to the this one, step 1. So here we are starting with the empty result array, nothing but this step, right? So next we will loop through each number from 0 to 2 and calculate the number of ones in its binary representation. So by 0, 1 and 2. So first iteration will be for 0, right? The binary will be 0. we are looping from 0 to 2, right? 0, 1 and 2. So the binary for 0 will be 0. So count of count of 1 is 0, right? So the result array becomes 0. Now the result array initially will become 0, right? So next step, for 1, the binary will be 1. The binary representation, binary will be 1. Now the result array becomes 0, 1, right? The count of 1 in 1 is 1. So there is no 1 present in the 0. So the count of 1 in 0 is 0. Now the count of 1 is 1. So we are updating the array with 0, 1. Next, the binary representation of 2 is nothing but 1 and 1, 0. So the count of ones will be 1. Here we can clearly see the count of ones will be, ones is 1. Result array becomes, now we'll update the result array by 0, 1, 1. Right. So the final output that we have got is 0, 1 and 1. The number of, basically the number of 0 has 0 ones in its binary form. Also the number of 1 has 1 ones in its binary form. The number of 2 has 1 1 in its binary form. So the overall output that we got is 0, 1, 1, which is equivalent to the output that is shown here, right? So the code works absolutely correct. Let me delete this. So yeah, what will be the time complexity and the space complexity? The overall time complexity would be big of n into log n. Why? The loop is running through n plus 1 times. So here you can clearly observe the loop is running through n plus 1 times, and for each number, binary conversion and counting is big of log n. Nothing but overall time complexity would be n into log n is nothing but big of n log n, right? So what would be the space complexity? The space complexity would be big of n. Why? The result array stores n plus 1 elements, right? So each holding a count of ones. So I'll just come here. Time complexity would be big of n into log n, and space complexity would be big of n. So let me comment this. Let me hit the submit. This works absolutely correct. Thanks for watching, guys.